great being here at the VIRION workshop. I'm Akseli Hemminki, the founder and CEO of Biotherapeutics. And one of the things I enjoy most in life is interacting with students. And Till obviously is trying to cure cancer, and the way we got to where we are now is I did a PhD in cancer genetics and then found the area of gene therapy and oncolytic viruses. Went to the US for 3 years to learn about that, and then nevertheless, to optimize my translational capabilities, I wanted to specialize in oncology and radiotherapy and returned to Finland to do that, and then set up my own group at the University of Helsinki. And my first biotech company was called Consortium, which is now listed in the Oslo Stock Exchange and the Oslo Index actually. So I guess it's doing reasonably. But when they were becoming independent in 2013, they didn't need me anymore. So I set up Tilt Biotherapeutics, whose unique idea is to really impact T cells, so the adaptive tumor microenvironment. So that's what we're trying to do.
Shall I go?
Yeah.
Okay. So I'm Marta. I did my bachelor in biotechnology in Spain, and after that I did my master in advanced immunology, and that is when I fell in love with that topic. So I decided to apply for a grant to do my PhD, and I applied for a Marie Curie, and I obtained a position in Amsterdam in the group of Tanja de Grauw, and I'm part of this VIRION Consortium, where we try to study how to modulate the immune suppressive microenvironment in melanoma by the use of oncolytic adenoviruses, and I focus my study on dendritic cells and which pathways may be involved in this suppression.
Okay, I'm João Santos, and I'm Portuguese. I did my bachelor's in Portugal, and my background is biology. I did my master's in cellular and molecular biology. And after doing my master thesis, I got this position, and I work for Tilt, and also for the consortium, of course. And I basically work on overcoming the safety and efficacy issues of adaptive cell therapy for solid tumors with oncolytic adenoviruses.
So, hi, I'm Teresa. My background is in applied biomedical science and infection biology, which got me strongly interested into viruses, and I'm also part of the consortium, and my take is to combine oncolytic adenoviruses with immunotherapeutic targets.
Well, I'm Victor Cervera. I'm a pharmacist by training, and then I was supposed to do my PhD in microbiology, but then when I was doing my master thesis here in Helsinki, I got my heart stolen from oncolytic viruses, so I had to change my whole future, and I applied for this Marie Curie consortium, and luckily I got a position here in Tilt, where I started in 2016. And my project in this regard relates to the use of oncolytic viruses to enable T-cell therapy related products, or more specifically immune checkpoint inhibitors.
And my name is Joanna Milanova, and I'm working with Orca Therapeutics through this Marie Curie consortium. And my project focuses on the immunosuppressive microenvironment, and I'm also trying to work with Orca in the preclinical development of their oncolytic virus.
Good.
So I have the feeling as a researcher, and after going to all this conference, that there's a lot of effort in trying to find new compounds and how, but we have so much already discovered that I feel that there's a lack of fundamental research in trying to understand really what is the molecular mechanism behind all these diseases and how we can apply what is already in the market to a new disease. And also a lack of effort in how to deliver properly a treatment, because when you have a systemic treatment, it doesn't really reach in high concentrations where you want it to be. and in imaging, try to have better screens. Yeah, what's your opinion?
Yeah, well, I more than agree. I think there were 4 or 5 questions there, but
Yeah.
and I think I agree with all of them. I mean, we do have a lot of compounds out there, and there's a lot to learn how to use them optimally. And maybe the clearest example is oncolytic viruses, which is our favorite topic here. When people started using them in patients, it wasn't taken into account that they cause pseudoprogression. So often the patient was taken off treatment, even though the pseudoprogression might have indicated that there's a lot going on with regard to the inflammation, and the patient actually might be benefiting. And sure, there's an endless amount of things you can do in the lab to create more knowledge. And I guess as a student, you need to choose which area you want to work in. I mean, basic research, translational, clinical research, those to me are the 3 main areas. And the challenges are quite distinct between those areas.
Yeah, I think that's one of the nice parts about oncolytic viruses, that you can actually condition in the tumor, because that is what some patients are lucky. And maybe in the future, with all these personalized treatments, you can check if the tumor has actually T-infiltration. If not, maybe timings are important. That's something that is being shown recently in science. So you can think about treating patients in different ways, and also timings and which doses and what compounds. I think that's also important.
Yeah, that's a good observation, that what oncolytic viruses are doing, they're conditioning the tumor.
Yeah.
And so, for example, if you become an entrepreneur and start writing up patents and stuff like that, there's a bunch of things are patented, like with regard to T cells and viruses. But almost nobody had realized that you need to condition the tumor to allow certain therapies to be effective.
I would like to ask a question, also considering that you're a CEO of Biotherapeutics. What would you use as a motivation for starting young scientists, not to be stolen by big pharma, but follow the academic career versus small companies and really focus, rather than securing their future and being part of the big machinery, let's say?
Yeah, that's a really tough question, because for smart people who are able to achieve things, there's many paths you can take. And to be honest, I don't think any one of us knows where we'll be working in 5 years. I mean, if there's one truth about the world, it's that it's a VUCA place, so volatile, uncertain, complex, and ambiguous. But if a student asks me that, I answer, just follow your heart. Where does your heart take you? Of course, I can, a student's mentor can try to help in having discussions, but really a mentor shouldn't make the choice. I mean, a mentor can just say, follow your heart, basically. There are very different areas of work in the academic life. I mean, eventually, you after 20 years of short-term appointments, you may get a permanent job. But then often you end up having a lot of administration, stuff like that. But I think many people who remain in academia, they do it because they like the students. I mean, it's so refreshing getting those fresh brains every year. And biotech, to me, is a way to move things along really fast from the lab to patients. And there's very little bureaucracy in biotech. I mean, the basic concepts are very similar to lab work. So if you've been a group leader at the university, you can make it in biotech. It's very similar aspects. I mean, so maybe at the university side, the grants are a little bit smaller. You need to apply for them more often. On the biotech side, you end up spending more time with the investors, and the grants or investments are fewer and far further between, but they can be larger. But it's a lot of time is spent raising money in both worlds. And I'll give you a chance in just a minute. But the big pharma, that's then a whole different story, because that's a huge industry. and the organizations are incredibly large. There's still a lot of money in drugs, and there's a lot of politics, and it's really difficult to even know where you end up in if you enter that machine. And for some people, that's okay. For those people who enjoy the organizational work and stuff like that. But some of these jobs are really, these companies are really tough. I mean, they might have a policy that each employee is graded into categories each year, and the least effective 10% are laid off each year. There's many companies who operate like that.
Yeah. Thank you.
Sure.
Yeah, I was going to ask you, how does your academic background influences your decisions in further developing therapy? Because we know that, academic is like somebody said earlier, that it's a free science, but at the same point, I mean, how does that view, academic view and free science view, influences the development of?
Yeah, that's a very key question, and unfortunately, this free science, for most countries, for most groups, it's a sort of a pipe dream. It's not reality. I mean, still there are some places in the world, even in Europe you might find some, but especially in the US you might find some of these really top-notch places where you're able to do what you like, and you're able to follow your nose. You discover something, you're allowed to go there, but for the rest, for the other 95%, you need to make compromises. And like here in Finland, it's very clear that the university is not having more money than they did. They're having less money, so they're really encouraging sort of working with companies, trying to get spin-outs from the university, trying to take the work somewhere. And even in those best places in the world, normally most of the money comes from grants, which means that you have to plan the work, and then you're supposed to do what the grant says. I mean, there's some leeway there. There's some flexibilities. What was the second part of the question?
Yeah. It is, how does this your academic background influences the decision of developing therapeutics?
Yeah. To be brutally honest, I mean, this sort of pure research, I tried it. I did my PhD on that. So it was during medical school. We were looking for new cancer genes. It was very, very successful. The papers that came out were really world class, but I didn't get that inner satisfaction from that. I felt the superficial satisfaction from having high impact papers, but it didn't please me in the inner way. And I realized that I wanted to apply it more to patients. So then for the next 5 or 8 years I thought, okay, maybe I could do it as an academic researcher, and in the US it might still be possible. There's still some labs which are able to come up with an idea, manufacture a drug and treat patients, do a phase 1 trial as an academic group. But then after I returned to Finland, I realized it's not possible here. And then we had this weird outlier, the Advanced Therapy Access Program, which was really a brave test. I don't think anybody else has done that. Taking advantage of this advanced therapy directive, the EU directive, which sort of encourages patient-by-patient treatment with oncologic viruses. And it was a fun time, but as we know, it didn't really end well. And you can read the book Crossing the Valley of Death with Advanced Therapy, published in 2015. It's only 12 euros. And after that, it was things became clear for me that if I want to take stuff from the lab to patients, it needs to be a biotech company. And maybe one of you is about to ask. I often get asked, is there a problem, conflict of interest between a lab in a company, but I really don't see any conflict there because, I mean, maybe I should be asking you guys because you're the ones doing the lab work, but the way I've seen it is that the scientists love they do the scientific experiments, they want to publish, they want their PhDs, and that exact same data can then be used with investors to try to take the advance further. It's unrealistic to do a clinical trial in the lab, and companies are usually not smart enough to be able to do the lab experiments that you guys are doing. So, yeah.
If I could, rather than a question, I would like to ask your advice. I come across my friends, acquaintances, asking me to explain them why they should believe in the old science. Because nowadays more and more people tend to go more for alternative treatments, alternative therapies. I would like to say like these wood science or whatever you call it, and whenever I'm trying to explain what I'm doing, usually I come across, or they take it as if I'm paid by Big Pharma already and that I'm losing the picture of what the regular person needs. Although I personally feel that I do know what a person needs, that's why I'm in this field. So what would be your advice? How could I explain to, or outreach to regular people, say like, science is good, you should believe in it, or like trust it, better, trust it.
Yeah, that's a really tough one, and it's very, very common, especially in oncology, and especially if you're in private practice in oncology. Almost every patient, or at least every other patient, they ask about these alternative treatments. So it's very important to understand the difference between experimental therapy and alternative therapy, because experimental means something which is based on science, which one day might lead to evidence-based therapy or not, while alternative is based on something completely else. But you cannot deal with the question by just dismissing it, because that's basically what they're looking for. You know, they're looking for further evidence of the big pharma oncologists sort of secret pact to make money off people who are ill. So, and I don't think anybody has a perfect solution, but the key aspects are just listening and empathizing, and often, so I do a couple of hours a week of oncology work, so there's always a schedule, so we have a certain amount of time, so at some point I need to sort of call it and say that, yeah, I can fully understand these things you're thinking about, but I'm trained as an MD, so I've received a biomedical training, and that sort of limits my scope. So I can answer from that perspective, and that it's fully within your rights as a human being to then have some other point of view. But with regard to science, there's only one science.
Yes.
Science is science, and then everything, the other things are not science.
Thank you.
I also have a question, because you just now advised us to follow our heart, right? Professionally, I mean. So, did you ever regret any decision taken with your heart? And in case not, what's the decision taking this way that you would change now?
Yeah, that's a really interesting question. I mean, when we started this Advanced Therapeutics program, that was really not a fully rational decision. It was very much a gut decision to just see if we can do it, if we're able to treat these patients with viruses that we had made in our lab. Then when there was the legal case, at some point I regretted it quite a lot. And now afterwards, I would say it was probably still worthwhile, but it's these sort of, when you're in the legal system being sort of pummeled around for 2.5 years, that changes people, and I'm not without my problems, so it's difficult to say which of those problems were caused by that period in my life. So I don't regret doing it, and I wouldn't take it back. But was it without consequences? No.
Can I ask you something else? So you previously told us that the world is a VUCA place, ambiguous, complex, etc. So then if the world is a VUCA place, where do you see yourself in 5 years?
Well, that's exactly the question that I cannot answer because of VUCA, but I promise to try to answer every question. So in fact, in leadership, the ability to be flexible and live in this VUCA world is one of the key factors of success. So the two most important factors of successful leadership is emotional intelligence, meaning that you're able to empathize with your employees and students and stuff like that, and then the ability to be flexible in a VUCA world. So I think in 5 years I will have a biotech company, whether it's Tilt or whether it's something else, I don't know. And every company is always for sale, so it's really difficult to say how long Tilt will last. Whether I'm working at the university, that's also an unknown. I mean, I don't like the bureaucracy at the university, but I love the students. And it's like every year that I get more and more senile, the students seem smarter and smarter. So it's like it's really a lot of fun. And right now it's a match made in heaven that we can have the company there and the group there. And so far there's been really no sort of conflict between those.
In line with this question that Joao just asked, did you always had clear, for example, you just said that you did your PhD, so did you have clear already at that time what you wanted to do after? Because you are also MD, so you had a lot of opportunities ahead of you. Did you knew back then what did you want to do?
No, absolutely not. So a big part of my life I was just going ahead without any clear goal. I mean, in high school I had no idea where to study, but I was very good in high school and I enjoyed the natural sciences, so I thought, okay, let's try the most difficult place here in Finland, because studying is free. The most competitive places are really competitive, and med school was probably the most competitive. So I thought, okay, let's try med school, and then I was able to enter, and then basically after 1 year, because I also like to get stuff done. So we had this research project that we were supposed to do. So I thought, okay, let's get this out of the way, and I figured I tried to figure out what's the most competitive group in the faculty. The group where I ended up going to had just published one of these hereditary cancer genes in Science. So I thought, okay, that must be the best group. So I just walked in. I hadn't even shaved or anything. Just walked in, and then the boss said, okay, I'll come back in half an hour and then we'll talk. And then, the student research project went well. That took about a year, and there was a great paper. I thought, okay, this went this easily. Why not just do a PhD? And then I ended up doing a PhD. And it's only after that I started thinking, what should I do next? Because medical school was about to end, the PhD was done. What do I really want to do?
So I think it's been mentioned before by Joao that there is a conflict between academia and companies. And I've been actually, during all my formation, during my bachelor's, I've been told that there is a real conflict. But in these 2 years as a PhD, I haven't really seen that it's such a different worlds. So you're really part of those two worlds. So have you ever faced any conflicts between the decision to publish some data or just to keep it inside your company as a benefit for companies? Would you also suggest companies to do so or to be more public? And then my second question...
You can ask that one later,
yeah.
because I forgot the first one. In my case, I've never had a situation where we had to delay a publication a single day. I mean, I've been part of, I think, 11 patent applications, and I would claim that no scientific publication was ever delayed at all because of those. I mean, the way it's done is you have a manuscript-like entity, and then you have a patent attorney write it into a patent application. But there's still a bunch of work to do from the manuscript-like entity to publication.
Mm-hmm.
And usually the patent application is submitted much earlier than the manuscript is about to come out. There is a lot of thinking in this traditional scientific community that somehow the commercialization is somehow evil and corruptive, but I think it's mostly based on ignorance. Those thoughts are from people who haven't actually done it, so they don't understand. I mean, if you have some data which is maybe about to lead to a clinical application one day, or is in company files, which will be submitted to regulatory authorities, that's actually submitted to much tighter, rigorous inspection than something that you publish.
Mm-hmm.
So if anything, company data is more rigorous than scientific data. And most small companies, biotech companies, do it like we do, that they publish everything because it's a good way to promote themselves. Almost all investors have a scientific background, and it's also because our memories are not that good. So if we don't publish it, we're not going to remember what we had done. I mean, we have that problem all the time. I have this recollection that we did something in 2001, but if we wouldn't have published it, we would never find it.
Yeah, and I had a small second question. As a PhD, I feel like I'm a little project manager, so I can guess that when you're postdoc or your PI, it gets even more hard. So would you suggest people in science to take some managing programs? Is it really essential to become a good PI?
It's not essential, but it can be useful. I mean, it's like a psychoanalysis. I mean, some people claim that that's useful for everybody, but some people can still survive and live a full life without the psychoanalysis. I mean, I'm doing an EMBA program right now, and I really like it. And it's so much fun being a student after being a teacher 20 years, and I'm learning so much every week. But it's also a lot of work, and it costs money. So it's around 50,000 euros to do it. There's many ways to roam. I mean, if you want to be let's say a leader in whatever field you want to be a leader in, you can either do it yourself, learn the skills, doing shorter courses, or you may elect, and maybe you'll have a chance to do a more formal training program. Many of the best leaders of the world never had any formal training.
I guess they have it natural.
Yeah, but I would claim that they're the exceptions. That for the 99% of the other leaders who became good leaders, they did have some leadership training.
No, it just feels like that only the exceptions, the ones that you remember.
Yeah, but it's also if you take a business course, let's say an EMBA, it's a lot about case examples.
Yeah.
So whether or not they tell about the real world or not, that's a different question, because it's business. It's not as scientific as, let's say, the biological sciences. It's sort of it's science, but it's a different variation of science. It's much more based on cases and opinions.
So do you also then work with, do you have face-to-face time with your classmates in the MBA or not?
Yeah, it's actually a pretty demanding program. So it's 90 European credits. So for the CNO people, it means 60 study weeks. So 60 weeks of work during 2 years. And about 2/3 is reading papers and articles and books and writing summaries and analysis and stuff like that. But for example, tomorrow I have I think 9-hour day of FaceTime there in class, and next week I have actually 2 overlapping modules. So I'm doing an evening module almost every day, and then when the weekend comes, I do a day for the other module and then the evening for the other module. So, but I view it as a hobby, so I don't feel it's, well, on most days I don't feel it's overly exhausting, although my wife says that it's completely led to burnout. But, you know, it's just so much fun learning about these things which are so relevant to your work, and it's so obvious how I can use these skills to become a better leader, and that's useful because then, you know, I can help cure cancer.
I can add something else. Previously, you were saying that in your role as an MD, you act almost as a consultant with patients, but at the same time, you yourself are a scientist, and I think you truly believe in the power of immunotherapies and oncolytic viruses. So, when you are working as a consultant, do you think you are always being objective, or do you push a little bit more for immunotherapies because you truly believe they are better?
Yeah, that's really a tough one. I do believe that I'm in favor of immunotherapies, so I end up recommending an immunotherapy more often than some other doctor would because I know what they can do.
Mm-hmm.
And it's just, if you're a believer, you're a believer. And I sometimes even say this to the patients, that look, my day job is an immunotherapist, that I'm a professor at the university and I have a company even trying to do this, so I believe in this approach. But, you know, it's always the patients who decide, and, you know, they often ask, okay, because the decisions can be very hard for them, so then they often end up asking, okay, what would you do? Okay, so, or, you know, let's say, how was your sister? What would you recommend? And then, of course, I would recommend immunotherapy often. But it's not in every case. You know, each patient is an individual, and I always use this sort of genetic testing of the tumor, so I get the information on how much PD-L1 there is, how many mutations, if there's microsatellite instability and stuff like that. So, and then I introduce to the patients that information, and we think about it together. But I think there's no doubt that patients who see me end up getting immunotherapy more often than patients that see somebody else. But it's just my philosophy. I mean, if you draw those curves, and I can draw. Will this be on the video as well?
We don't know. We can check.
So if here's the proportion of patients surviving a diagnosis, and if you don't give them any treatment, here's their survival. If you have an effective drug, let's say chemotherapy, here's their survival. So the median survival can be improved, so the drug works, but the end result is the same. Every patient is dead of their tumor. But then when you draw the line for immunotherapy, the median survival might not be improved that much, but then there's the tail. And now we have data for 10 years or more that the tail doesn't go down. And, you know, every patient wants to be in this tail, and every oncologist wants to be the oncologist who gave the patient a chance to be in this tail. When you present it like this, you know, who wouldn't want to receive immunotherapy? I would. So this has been a lot of fun. I really enjoyed it. Some of the questions were a bit provocative, but that's the way we like it. So keep on asking those tough questions. Yeah.
Thank you for the answers.
Thank you.
Yeah.
Thank
Thank you
very much
for your
your time.
contribution.
Yeah.
It's really amazing how the next generation is, you know, outsmarts the older senile people very fast.
Perfect. I think we can.
Yeah, thank you.